Section 8.2, solving equations by factoring. So the first part of these notes are basically, copy right from your textbook that explains, if you're looking at a polynomial equation in the form of ax squared plus bx plus c, the product of the coefficients is essentially the first part of FOIL. The sum of the coefficients is the outer and inner products. That's the b. The first term and the last term have to add up to b in the middle, and then the last term c is the product of the last terms. So if we're looking at this example below, in example A, we can factor out the largest common factor of 4, 26, and 42. And that's going to help our factoring of this problem. So if I factor out a 2, essentially, right, this is essentially like 4 divided by 2, 26 divided by 2, 42 divided by 2. I can pull this 2 out and put it on the outside of parentheses, right? And this, if you were to FOIL this back out, you would get this again. So we can factor out the 2, and then we'll have a smaller equation to figure out. So let's scroll down the page. We were looking, we pulled out the 2, and I'm just rewriting it here so I can see it for myself, but of course you have it right above you on your page. 2x squared, 13x, and 21. Right, so we have to figure out, well, what are the pairs of factors of 21, right? And we have, 1 and 21, and we have, 7 and 3. And the reason why we're concerned about the factors of 21 is, right, some combination of the factors here and some combination of the factors here have to add up to that middle term. So if we're looking at this, 1 and 21, right, that adds to 23. And 3 and 7, right, 3 and 7, wait, let's see here. Got a little ahead of myself. Right, so we're concerned also about the factors of 2, right? And what are the factors of 2, right? And these notes kind of don't also say. You want to know the factors of 21 and the factors of 2. Well, what's the factors of 2? 1 and 2. And so here's the factors of 2, here's the factors of 21, and we try to take various combinations, right? Well, if I go 1 times 1 and 2 times 1, or 1 times 21, not my mistake. 1 times 21 and 2 times 1, does that add up to 13? Nope. And then if I take, what about 1 times 7 and 2 times 3? You have 7 plus 6. Does that add up to 13? Sure does, right? So this is what looks like going to be our magic combination. But you can try the others, see if anything else works. 1 and 3 and 2 and 7 is 1 times 3 plus 2 times 7. What is that, 14 plus 3? 17? Nope, that doesn't work. And here's 21 and 1. So we could also try, 1 times 1 plus 2 times 21. And you get, what's that, 42 plus 1, 43. And that doesn't work either. So we're going to break this down here. This 2x squared and into basically the component parts. We've determined that 1 and 7, or 1 and 2, and 3 and 7, these are the factors we should use. So bear with me a moment. On the next page, we're gonna break down this 2x squared plus 13x plus 21. So here it is, right? And we determined that, well, the factors of 2 that worked, right? We had the factors of 2 that worked were 1 and 2, right? I mean, what else could they be? And the factors of 21 that worked, and by worked, I mean they added up to 13 eventually, 3 and 7. So we essentially have, 1x and 2x, right? This is the part from A, 1 and 2. And then we also have, 3 and 7. So essentially x plus 3 and 2x plus 7. And remember, we factored out the 2 to get us there. Now your factorization of this thing is complete, right? 2 times x plus 3 times 2x plus 7, that's going to equal 4x squared plus 26x plus 42. And we know also from chapter 7, right, the zeros of this equation, well, you're going to have a 0 at negative 3, and you're going to have a 0 at, I believe, negative 7 halves. And if you wonder how I figured that out, well, we got x plus 3 equals 0. What makes that 0? Negative 3. And 2x plus 7 equals 0. You subtract 7 and then divide by 2. You're going to get a 0 at negative 7 halves. And fractions are numbers, folks. So some of these answers could be fractions. And in chapter 11, we're going to get to where some of these answers are not even real numbers. They're imaginary numbers. So we're going to get to that about 2-3 chapters from now. So here we go. Let's try another example. So looking at this thing, 20x squared minus 40x minus 25. Between the terms 20, 40, and 25, there's probably a number we can factor out. And the number that comes to mind that they all share in common would be a 5, right? And if I divide everything here by 5, I can simply pull it out and put the rest of it in parentheses. And the reason I do this is it just, it makes factoring the rest of it with a lot smaller numbers. So, 20 divided by 5 is 4. 40 divided by 5 is 8, right? That's where they get these figures. Negative 25 divided by 5, negative 5. So now we're concerned, right? We're concerned most with the factors of 4 and the factors of 5 because they all have to somehow add up to a negative 8. So on this column, right, here's all the factors of 4. Well, we got 1 and 4, 1 and 4, 1 and 4, 2 and 2, 2 and 2. And the factors of negative 5, we got 1 and negative 5, and so on. They're all right here. So if we do 1 times a negative 5, right, we go 1 times a negative 5 and 4 times 1. You're going to get, negative 5 plus 4, negative 1. And that, of course, is not 8. It's not negative 8. So we got to keep going, right? We've checked this pair. And now let's try, what about if we switch them around? 1 and negative 1, 4 and 5. So 1 and negative 1, 4, and 5. So you get 20 minus 1 is 19. We've checked it. It's not 8. It's not negative 8. So let's keep trying. Let's try 1 and 5. 1 and a positive 5, right? And 4 and a negative 1. So we got negative 4 plus 5 is positive 1. And again, that's not negative 8. So that doesn't work either. And if you're like, this is a lot of steps, I mean, yeah, this is like a trial and error type of thing when you're trying to figure this out by hand. So let's try another combination. We have to exhaust all possibilities. And, maybe now algebra tiles is looking pretty good to you to figure these out. But let's just keep going. We're going to try now next. What about, let's switch them around. 1 and 1 for a negative 5. 1 and 1 for and negative 5. You're going to get negative 20 plus 1, negative 19. Nope, that doesn't work either. And let's keep going. We're going to go 2 and negative 5. 2 and 1. So you got negative 10. Plus positive 2, negative 8, ding, 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 ding. Because we're trying to get to negative 8, right? Then we can figure out our factors. And we should know that this other combination, 2 and positive 5, 2 and negative 1, it's not going to work. 10 minus 2, positive 8. Not going to work. So we know the first part, 2x and 2x. So we've got those that first pair of factors, and now we know the other pair of factors is a positive 1 and a negative 5. And then we use the combination of factors to find the value of negative 8 for b. And then, of course, we had that common factor of 5. So this here is a complete factorization of 20x squared minus 40x minus 25. And if you were to multiply this all out again, like this part, if you were to multiply this part out, you would get this. So in Chapter 7, we kind of went from here to get to there. Chapter 8, we go from here to get to there. So let's take a look at these two examples. The first thing I try to figure out, well, is there a common number between 5, 8, and 4 that I can pull out? And they don't share a common factor, so I can't do that. So then I have to ask myself, well, what are the factors of the A part and the C part of this equation? The factors of negative 5 are basically 1 and negative 5, or right, we've got negative 1 and 5. And then what are the factors of 4? Well, there's several, right? 4, we have 1 and 4. We also have 2 and 2. So somehow, through a combination of the factors of part A and the factors of part C, we've got to add up to 8. So let's see. I'm going to do a table, right? Table. And I'm probably going to take this work onto another page, just because we're going to run out of room with this limited space, at least for me and the pad and the video. So bear with me a moment. Actually, I'm just going to write it over here. Got the factors of A, got the factors of C. Let me get some more room. Factors of A, factors of C, and then what they add up to. So the book uses the table method, so let's go with that. So we've got 1 and -5, and we got we can try 1 and 4. So let's try, what's 1 times 1 plus 5 times -5 times -4? -5 times +4. And you get basically -20 plus 1. And that's going to be a -19. So that doesn't work. What if I tried 4 and 1 instead, and I kept 1 and -5 the same? Well, 1 times 4 is 4, plus essentially -5 times 1 is -5, and that equals a -1, and that doesn't work either. So let me try, I'm still going to go with 1 and -5, but now I'm going to try the other factors of 4. 2 and 2. So 2 times 1 is 2, and a -10 is the result of -5 times 2. So 2 plus a -10, does that equal a -8? Or that equals a -8. We're looking for a +8. All right, +8. So if we're looking for a +8, the 1 and the -5 isn't going to work. What about a -1 and a +5? So you can see, right? I mean, I don't necessarily know the answer when I start, but I kind of, through process of elimination, eliminate, various combinations. And it is a little tedious, but this is kind of the way to go about factoring these out. So I'm going to try -1 and 5, and then again 2 and 2. So 2 times a -1, we've got a -2, and then 2 times 5 is 10. 10 minus 2 does equal 8. So this is our factor combination. So this is going to factor into essentially, I'm going to list the 5 first. 5x and a minus x, and then we went with +2's, right? +2 +2. Now let's take a look at number 7 here. I'm going to ask myself, is there a number between 12, 48, and 45 that I can pull out? And the number that comes to mind is 3. Right? These are all divisible by 3. So if I pull out a 3, I'm going to be left with, 12 divided by 3, 4x squared. 48 divided by 3 is 16x. And 45 divided by 3 is 15. And now hopefully by pulling out this 3, I have smaller numbers to work with, which essentially means less of these combinations to try. So you're going to want to try to factor out a number, otherwise you're going to give yourself essentially more work to do. So let's see, now we're concerned with the factors of 4 and the factors of 15, because we're trying to get them to equal the middle term of 16. So again, what are the factors of 4? Right, we got 1 and 4, or 2 and 2. And if you want to get really fancy, this is a future possibility in more complicated problems, right? -2 and -2 also equal 4. And then what are the factors of 15? There's several. Right, we got 15 and 1, and 3 and 5, or you can make them both negative, and those would also be factors of 15. So let's just get busy with a column here, and we can try to figure this out. B, and C, right? And you'll likely definitely need to write stuff down to try to figure these out. Let's just try combinations. And we're trying to add up to 16. So I'm thinking, the 4 part might be a little bit too high. So I'm going to try 2 and 2. 2 and 2. And let's just try, 3 and 5. And I don't know if this is going to work, but let's just see what happens. 2 times 3, right? If I do 2 times 3, I got 6. And 2 times 5 is 10. And hey, I lucked out, right? First try, I get 16. So that's going to be the way this factors out. Now, of course, you could try, there'd be many other combinations you could try. I just got lucky, and on the first attempt, I was able to factor it. So it's going to be 2x plus 3 times 2x plus 5, and all that's multiplied by the 3 I factored out. So then this here is the answer for the factorization of this thing. So I know there's a lot here to take in, but we are going to practice a lot. We can also use our algebra tiles if needed, and just practice and trial and error is the way to figure these out. So I've got a few more examples here. All right, we're concerned with the factors of 6 and the factors of 1. And the good news is, right, 1 only has the factors of 1 and 1. So if you were building your equation, right, essentially, this one's going to be a 1 and that one's going to be a 1. And then they're probably both going to be pluses. And what else? So let's see, factors of 6, right? We've got 6 and 1, or 2 and 3. So I'm going to go with the 2 and 3 pair, right? Because I know 2 plus 3 is equal to 5, and that's my goal there, is trying to figure out the middle term. So this is going to be a 2x and a 3x, and that's done. It's completely factored. And if you multiply this thing out, you're going to get this. So let's try another one. In number 2, right, 9, 33, and 30, these are all factorable by, I can pull out a 3, right? Divide by 3. So when I pull out the 3, I'm going to be left with 3x squared plus 11x and then plus 10. And what are the factors of 3, right? 3 and 1. So I know if I'm building my factors, this is going to be a 3x and that's going to be an x. How come? There's only one possible combination for the factor of 3 and 1. So now all I have to concern myself with are the factors of 10. We've got 1 and 10 and 2 and 5. So I'm trying to add up to 11, and I know 3 times 2 is 6, and 6 plus 5 is 11. So this is going to be a 5 here and a 2 here. And how do I know where to put them? Well, in the FOIL process, right, eventually I need to figure out, what's going to make 3 times 2? What's going to make that situation occur? And it will only occur if I put the 2 right here. It will not occur if I put the 2 there. So this is the answer, right? This is the factor of this, 3x plus 5 times x plus 2, all multiplied by 3. So let's let's just keep plugging along here. And number 3, there's no common factor between 4, 8, and 3. So, but there is only one factor for 3, right? 3 and 1. So if I'm building my equation, right, I know one of these is going to be a 1, and one of them is going to be a 3. It's just the only option available to me. So then all I really have to concern myself is the factors of 4, right? That A part. Well, we've got 2 and 2. We've got 4 and 1. And I'm trying to add up to a negative 8. So one of my terms, one of my operations here and here is going to have to be negative, and possibly both of them. So let's see what would happen. So if I make this a negative 1 and a negative 3, when I multiply them together in the FOIL operation, right, I'll still get my positive 3. But now I need to figure out, well, how do I get negative 8? If I put a 4x here and a 1x here, right, you can just do trial and error. You're going to wind up with the 4x squared, but you're going to get you're going to get basically 4 times a negative 1 and negative 3 times 1, and that's all going to add up to a negative 7, which is not 8. So that combination is not going to work. So the only combination that's going to work, it appears, is if this were 2, and let's just see if that happens. And it would. That does work, right? Because 2 times a negative 1 and negative 3 times a positive 2, when I add them together, you do get negative 8. So the factorization of this thing here is 2x minus 3 times 2x minus 1. And hopefully you picked up a few strategies about how to figure these out. So I'm going to erase this part here. And then I'm going to proceed to the factoring of problem 4. So I'm going to do this part with you live in class, and let's see if we can hash out some strategies to apply on this example.